Hi, welcome to 2.2 Skills for Working with Rational Functions. Our success criteria. We're looking at being able to simplify rational expressions by adding, subtracting, multiplying, and dividing them. And finally, stating the restrictions on the variable. Okay. Rational expressions are any expression that maybe is in this form. So this is where we might have an algebraic expression on the top, or we might just have a constant, but we will have something algebraic in the denominator. Okay, and it can take on many different forms. It could also look like, maybe we have 5 over the square root of x squared plus 1. That's also an algebraic expression. Okay, we may also have variables in the numerator as well. So those are all examples of rational expressions. The word rational, you can just think of it as fraction. So why do we need to be able to work with rational expressions? Well, they do show up in different scenarios. So they show up quite a bit in the sciences, going back to what you guys did in grade 10 science. And when you're working with light and lenses, you would have seen maybe something similar to this. Basically just allows us to maybe calculate where a lens should be positioned in order to have an object and have its image reflected, or doing various calculations. So this one on the left, this would be if you were taking any course in electric circuits, and these little things here, these symbols, those are for resistors. So to calculate the total resistance in the circuit, you need to add the reciprocals of each one. So here we're adding a bunch of rational expressions together, and just like we are here. So this is going to be split up over a 2-day lesson. The first part, we're going to learn how to multiply or divide rational expressions, and we're going to follow these steps. So we're doing multiplying and dividing before addition and subtraction because it actually is a bit simpler. So to multiply and divide rational expressions, we first need to factor any polynomials in the numerator or denominator. And if we're dividing them, then what we need to do is we actually need to multiply it by the reciprocal of the rational expression. And if you remember, in order to divide fractions, so if we were doing, let's say, this question here, in order to divide fractions, we have to multiply it by the reciprocal. So you guys probably heard the saying, flip and multiply, right? And that's what we're going to need to do with these ones as well. And remember, when we multiply fractions, remember we just multiply the numerators together and we multiply the denominators together. So we would get 5 over 10. And then we simplify down to 1/2. So that's really how we're going to be tackling these rational expressions in the same manner. So yeah, we'll look for common factors whenever we want to simplify, like I did going from 5 over 10 to 1 over 2. I basically divided out a 5. That was common from both. And the only other thing we need to do with rational expressions is we have to state any restrictions. So when we start manipulating our rational expression, we want to say this is equal to this. Well, there may be some restrictions that are going to come up along the way, such as dividing by 0, that we'll need to make sure we take care of. Okay, let's get started. So this first example, we're going to simplify each expression and state any restrictions on the variable. So in question A here, I'm just going to write it out. 4x squared over 3x times, sometimes you might see the multiplication as a dot because we are using x as a variable and we don't like to use it again as multiplication sign. So I'm just going to leave the dot here, and you may see it this way in the textbook. So 4x squared over 3x times 12x cubed over 2x. Okay, we're going to multiply these, and then we're going to simplify, and then state restrictions. So we're going to multiply the numerators and multiply the denominators first. That's supposed to be an and symbol. Let's try that again. Multiply numerators and multiply denominators. I'm going to try to write this a little bit small just so I can fit everything in. It's not a lot of space here, so just be careful of that while you guys are completing the handout. Okay, so 4x squared times 12x cubed. So essentially this is what I have. I have 4x squared times 12x cubed. That's going to be my numerator. In the denominator, I'm going to have 3x times 2x. Okay, you don't have to write this step out. You can kind of just go from here to this next line where we multiply. So multiplying these together, we're going to have to do the coefficients first. 4 times 12, that's 48. And x squared times x cubed. When you're adding powers with the same base, you have to add the exponents. So x squared times x cubed is actually x to the 5, right? We have to add these together. Divided by 3 times 2 is 6, and x times x, x squared. And now we can divide out any common factors. So I can divide out 6 from both sides. So I can divide this by 6 to get 1. I can divide this by 6 to get 8. And I can divide x to the 5 by x squared, and that will give me x cubed. So that will be gone. When everything in the denominator cancels, it's not 0. It's actually just going to be a 1 because essentially I have a 1 from here. 6 divided by 6 is 1, and x squared divided by x squared is also 1. So I have 1 times 1 on the bottom, which is just going to be 1. So don't ever get confused about what to put on the bottom. It's just going to be 1. 8 times x cubed, so we'll have 8x cubed on the top. Now, we don't really need to write out 8x cubed over 1. We know that when we divide something by 1, it's just going to be whatever it is. So our final answer is just 8x cubed. Now, we do need to state some restrictions. So to say that this is equal to this, well, yes, it is, but it only works for certain values of x. And what I mean is, in this simplification here, I can put 0 in for x, and that just gives me an answer of 0. However, I can't put 0 in up here because then I'd be dividing by 0, and that's undefined. So if I'm going to say that this is equal to this, well, that needs to be true all the time. So since it's not for x equal to 0, we need to state that. We're just going to say x can't equal to 0. So to get these restrictions, what I do is I kind of start with my question, and I look for any factors in the denominator, and I see what will make it 0. And I first look in this line, and then I look in this line, and I just keep kind of scanning along the way. And any of them that come up, I make sure I mention in here. All right, so that's the first one. I know it wasn't too hard, and there's probably a different approach you could take to getting this. So you could also do your cancel out your common factors. You could also do that up here. You don't have to wait till you multiply. You could do like 4 over 2 and simplify that to a 2. You could cancel these two x's out with this one here. So there's other approaches you can take as well. But I think a nice easy way is to just multiply everything and then do your canceling out in the next line. Okay, I'm just going to shrink this a little bit so that we can tackle this next one, B. Okay, so in this one, we get to do the division of rational expressions. So we have 10ab squared over 4a divided by 15a squared over 12b. So as you remember, when you're working with fractions, when you divide, you need to flip and multiply. So we'll say here to multiply by the reciprocal. That's our first step. So that means we're going to have to flip this second term. So 10ab squared over 4a. This time we're going to multiply. You can use a dot if you want, or an x. Both are fine. We'll have 12b over 15a squared. Now I can just multiply numerator and denominator together. Sorry, let me do this here. Multiply. I'm just going to write numerator and denominator in short form like that. Okay, multiply. So just multiply directly across. All right, start with the coefficients. 10 times 12. That's going to be 120. And then a times, there's no a over here, so I'm just going to have 1a. And then a b squared times a b, same base, add the exponents, we get b cubed. And the denominator, 4a times 15a. So start with the coefficients, 4 times 15. That's going to be 60. And a times a squared, a cubed. All right, now we get to cancel any common factors. Okay, so we can say divide out common factors. Okay, remember just like last lesson, I said you can never cancel out or divide terms. You can only do it with factors. So this is great here when we have stuff in this form. This is only one term. And 120 is a factor, and then we have a and we have b cubed. And yes, 120, you could take that number and you could factorize it to 12 times 10 and then break up the 10 and the 12 to 5 and 2 and 4 and 3. And then you can do the same for 60 and then cancel out those two as well. But I feel like that's just like a little bit of unnecessary work. So anyway, we can, looking at the coefficients first, I can see that I can divide out by a 60. So when I divide that by 60, I get 1. When I divide that by 60, I get 2. And I notice I have an a on the top and an a on the bottom, so I can divide 1a out. So I'll have 1 for that, and that will go to a squared. So we have 2 times b cubed. So I have 2b cubed over a squared. So that is the result of doing this division right here. Now I just need to state any restrictions. So I first start with my initial question. Because this is division and I flipped after, I need to make sure that I scan this one and I scan this one. So anyhow, let's first look at this top line, my denominators. So these can never equal 0, so that means a and b can't be 0. So a and b cannot equal 0. Those are my restrictions. Notice they hold true in the next line. A can't be 0. And I can look again and I can look again. So I've already included a can't be 0. So that is finished. Okay, what you don't want to do is you don't want to skip this one, right? Because when we go down to the next line and when we flip and multiply, you don't want to just check these here. You have to make sure you check the one from the initial question. All right, so yeah, that's pretty much it. Multiplying or dividing rational expressions. We're going to continue in the next example with some that are just a little bit more complicated, but we'll be applying the same process. Okay, so we're going to simplify and state any restrictions. So notice these look a little bit more complicated, but that's okay. Like, for instance, now we have 2 terms here, and we have 2 terms here. So we're kind of multiplying rational expressions that look a little bit more complicated, but anyway, it should be fine. So what I like to do is before I multiply these together, So I'm going to start this one over here, but then I'm going to compress it and move it over. So maybe in your handout, you can kind of squeeze this in over here. We have a squared plus 2a over 3a times 20a squared over 5a squared plus 10a. Okay. Now, before I multiply these across, I try to do any factoring that I can. So is there any factoring I can do with this? So as soon as you see like more than one term in one of these areas, then try to do a little bit of factoring. So I see there's an a in both terms that I can take out here. Same again down here, I can take out something. So let's go ahead, let's begin. I'm going to write factor where possible. So they are binomials. So I'm going to say factor binomials where possible. So I can take an a out from the first term. This is just common factoring, and we would have a plus 2 inside the bracket. So I just common factored an a out, and I got this. Then we have 3a over here, and then we have multiplied by 20a squared over, and in this term here, in this expression here, I can take out 5a. That's my greatest common factor. So I can take a 5 from both terms and an a, and I'd be left with a plus 2. After you do this common factoring, sometimes it's a good time to take a quick check, make sure you did that correctly, and that you have the same thing up here if you were to expand it. All right, so that looks like it's all good. Next thing I do is I try to do a little bit of simplifying. So divide out any common factors. So I'll say divide by common factors. So what are some of the common factors? Well, I see an a here and I see an a down there. I can divide those by an a. And remember, whatever you do to the top, you need to do to the bottom. That way you're not changing the value of the expression. And we can also do some of that over here with this one. So 20, I can see I can divide that by 5 and this by 5. And I can also take out an a from this and from this. Okay, so let's go ahead and do that. So we'll divide this by a to get 1, and we'll divide that by a to get 1. And then let's write down what we have just so we don't make any errors. We'll write a plus 2 over here over 3. And then now in this part, like I said, we can divide by 5 here and here. So this would work out to 4, that would work out to 1. And I can also divide both by an a, so that would work out to 1, like a to the exponent 1, and that a would cancel out to just 1. So for this one, I would have 4a in the numerator over 1 times a plus 2, that's just a plus 2. Okay, and I'll put that in a bracket. All right, so you might see, hey, there's something else we can cancel out too as well. So because these are being multiplied by each other, this factor up here can cancel out with this factor down here. So we can also do that as well. So if I divide this by an a plus 2, I get 1. And if I divide this by a plus 2, I also get 1. And then I'm left with 4a over 3. Now I just need to state any restrictions. So this is why when we go from here to here, we always want to factor. So like our first step is always factoring. So when we put stuff in factored form, it makes it easy to find any restrictions. So my restrictions, I like to say a cannot be equal to. So looking here, 3a, I know a can't be 0 because that would make that 0. Same with up here, right? And then for this denominator, I can check in here where it's factored. And what would make 5a 0? Well, a would have to be 0, and I already mentioned that there, so that's okay. This factor, though, a cannot be negative 2, because that would make this 0, right? So that's my second one right there. So a can't be 0 and negative 2. So also, I mentioned this, I kind of wrote this down a little bit poorly. We should put these in ascending order, so we should have the negative 2 listed first. So it's nice to put all those in ascending order. I'm just going to erase that and fix that. Do negative 2 and then 0. That's just the proper way to do that. So that's it. We just simplified that rational expression there. Okay, we're just going to compress this and get this out of the way. Okay, let's start the next one, B. So if you want for our first line, why don't we start with a little bit of factoring? So I have a binomial here, and it looks like I can only take out a common factor of 2, because I can take 2 out of both, and then I can also take an x out of both terms. So we can take out 2x, that's the greatest common factor. So we would have x minus 4. So this here is just this here right there. And you can check it by expanding. And then this would be over, now we have this one here. So x squared minus 3x minus 10. So I can see that I can factor this. This is just simple trinomial factoring. So off to the side here, I need a product of negative 10 that needs to add to negative 3. So I could do negative 5 and 2. So this has a product of negative 10, and negative 5 plus 2 does give negative 3, the middle term. So those are the factors for that trinomial. So we'll say x minus 5, and then x plus 2. Okay, so this is just this expression right here. Now, before I flip and multiply this, I'm going to factor as well, and then in the next line, I will multiply by the reciprocal. So for now, we're just factoring. So I'm going to leave it as division, and we can write 4x squared over, so x squared minus 9x plus 20. So we're going to factor this. This is just simple factoring as well. We need a product of negative 20 and add to negative 9. So we can do it's positive 20. I'm sorry, positive 20. Yeah, it's positive 20 and add to negative 9. So that's easily just negative 4 and negative 5. Sorry, negative 5 times negative 4. That has a product of positive 20 and adds to negative 9 in the middle term. So we'll put x minus 5, x minus 4. So that's our first line. We factored everything. Now we can go ahead and flip and multiply. So this will be 2x times x minus 4 over x minus 5 times x plus 2. And then we're going to be multiplying by the reciprocal, x minus 5 times x minus 4 over 4x squared. Because we're multiplying these two expressions, these are all my factors on the top, or the numerator. These are all my factors for the denominator. So my next line, I can divide out the common factors. So we'll say here, divide the common factors. Okay, so kind of take a quick scan across, and it's not, I'm not just canceling stuff out like from here and here. I'm also doing it like anything from this side and this side. So they just have to be opposite to each other, obviously. So because when we look at this, we have to think of this all being multiplied together. So I'm actually just going to write it out this time, just to make sure we kind of get it. So this is like what my factors look like when I multiply. So I have to multiply both numerators together and both denominators together. So I'm canceling out any common factors. So I see an x minus 5 up here. That can be divided out like this one here. So if I divide this by an x minus 5, I get 1. So I'll put a 1 there. And if I divide this one by an x minus 5, I also get a 1 here. All right. I also see right here, I see a 4. I can divide that by 2, and I can divide this by 2. So dividing 2 by 2, I get 1. Dividing 4 by 2, I get 2. I can also cancel out the x. So if I divide this by x, I get a 1 for that. And if I divide this x squared by x, I just get x to the 1. So my next line is going to look like x minus 4 times x minus 4 over x plus 2 times 2x. Okay, and we could simplify this just a little bit further. It's not necessary, but you could write this as x minus 4 squared, because we have this factor times that factor to give us the perfect square. And then I like to write it this way. We can write the 2x in front of the x plus 2. So instead of leaving it like this, I kind of drop the brackets on the 2x in front here and just leave it like that. So that looks just like a little bit cleaner. Lastly, we go ahead and we state any restrictions. X cannot be. So I factored everything first, so I can go ahead and I can take a look up here and state any of them. So I'll write them underneath each one. So this one, x can't be 4, because that would make that 0. X can't be 5 for that one. That would make that 0. This one can't be negative 2. And this one can't be 5. So it looks like 5 is listed twice. Now, when we go to the next line, because we flipped and multiplied, we now have an x squared on the bottom. So I now got one more to consider, this one at 0. So I need to go ahead and list all those in ascending order. So we can say x can't be equal to negative 2. Then we have a 0. Then we have a 4, and then a 5. And that's it. So these will take a little bit of practice to kind of get quick at and get good at. And I do want to encourage you guys to make sure you do learn how to do these well, because it's something that's going to kind of probably keep sneaking up a little bit in future math classes. So the better you are at this skill, the easier it'll make your life for those other classes. So okay, that is it for this lesson, multiplying and dividing rational expressions. I will see you in the next one where we learn how to add and subtract them.